Hello class, this is a continuation on further application of factorial notation. So purely algebraic applications of or problems of factorial notation can be encountered and solved. These skills that we're about to look in this video will be used more extensively in later units of work. So here we go. Let's using factorial notation, let's prove the following. So you can't use a calculator for this, just using the factorial notation. I'll take you through in this video these two examples, and I'll leave this one for you to solve in the exercise. I will solve it later on in a different video. Likewise for these, I'll be taking you through these two in this video, but I'll leave this one for you to solve on your own. So here we go. So, factorial notation. Now recall that factorial notation literally means the number you start on, so n factorial means we start on the first number given, then we multiply by the number by the number one less than it, then we multiply by another number one less than that one again, so two less than this one, and so on all the way down to 3 times 2 times 1. So using that idea, let's take a look at what 9 factorial means. No, sorry, 99 factorial. 99 factorial means 99 times, actually I like doing this one a little bit better, 99 times 98 times 97 times 96 all the way down until 3, 2, and 1. So that's the numerator done. Let's take a look at what the denominator states. We're starting on 98 factorial this time. So 98 times 97 times 96 dot 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 all the way down to 3 times 2 times 1. Now take a look. Because this is all multiplication on the numerator being divided by multiplication again, we have common factors. We can start cancelling out pretty much everything. Cancelling every common factor, leaving us with just 99. And there we have it. So I want you to go ahead, try it again for this one. You can go ahead, pause the video, try it yourself, or even try it with just algebraic notation here. Okay, once again, nice and simple. 72 factorial means 72 times 71 times 70 times all the way down until 3 times 2 times 1. And we're dividing that, this one here, by 71 factorial. And I'm pretty sure you're seeing the pattern here, 71 times 70 times dot 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 times 3 times 2 times 1. We have common factors all around. They cancel with everything, leaving us with just 72. So hopefully that's rather clear for you. I want you to go ahead, try it with this one, but I'll leave the solution to that in a later video. Here's another one that I'd like for you to try. 8 factorial divided by 4 factorial equals 8 times 7 times 6 times 5. And for this one, 15 factorial means, or divided by 7 factorial means 15 times 14 times all the way down times 9 times 8. I want to draw your attention very carefully to notice how the number it ends on is one more than the number we're dividing by. Likewise with this, 7 factorial, but it stops on 8. And this here is the general term for this. We start on n and we're dividing by any number, assuming that n is bigger than r. And notice how for this, we're always stopping one number bigger than what we're dividing by. And let's take a look at how this works. So let's just use the notation for factorials. 8 factorial is 8 times 7 times 6 times all the way down until 3 times 2 times 1. For 4 factorial, actually for this, we're going to need to show this. You'll see why in a moment. 4 factorial is 4 times 3 times 2 times 1. I just realized, why not just show everything? There's a 5 just missing there. So we're showing this in factorial notation, expanded factorial notation. And by common factors, 4 cancels, 3 cancels, 2 cancels, and 1 cancels, leaving us with 8 times 7 times 6 times 5. And there we have it. Here we are. Here's another example. Let's show that 15 factorial divided by 7 factorial is 15 times 14 times all the way down, this time only stopping at 8. So let's show this using expanded notation. 15 times 14 times, I'm gonna skip down, times 7 times 6 times 5 times 2 times 1. You'll see why I started on the 7. 7 factorial is 7 times 6 times 5 all the way down until times 2 times 1. There are now common factors we can cancel, which leaves us with 15 times 14 times all the way down until times 9 times 8, because the next number here, remember, if we were to write this out again, which I think in hindsight I should have done that, I should have included that 8 there, because now we know it stops at the 8. So these two here kind of lead you to answer this one. So I'll leave you to try this yourself. And likewise with these two examples on the left should hopefully show you how to think about how to answer this one as well. So I hope that gave you an insight into how we could further use factorial notation. And be sure to keep this skill because it'll be very important as we move into later units. So I hope to see you in the next video. Best of luck.